Today we're talking about two special combinations, perfect square trinomials and difference of squares. And these patterns are just going to make things a little easier for us. So we've done the first pattern already. When we have a quantity squared, what does that mean? What does it mean to square something? Right, it means to multiply it by itself, right? So if we have x plus 3 times x plus 3 and we FOIL it, first, outside, inside, last, with these problems, the outer and inner terms are always exactly the same. So it makes it a little bit easier to add them up, x squared plus 6x plus 9. Or if I have x minus 2 quantity squared, x minus 2, x minus 2. I just got to watch my signs, x squared minus 2x, x squared minus 2x minus 2x minus 4, plus 4, right? Or x squared minus 4x plus 4. What if I have 2x minus 1 quantity squared? Well, same thing, right? You're just going to write it 2 times. 2x minus 1, 2x minus 1. Or 4x squared minus 2x minus 2x plus 1. Or 4x squared minus 4x plus 1. And then finally 4x plus 3 quantity squared is 16x squared, 12x plus 9. So you got a little tougher there at the end of the row, but it was the same idea that the inner and outer terms were always the same in this perfect square trinomial. In perfect squares, we've talked about in your past math classes, like 1 is a perfect square because it's 1 times 1. 4 is a perfect square, 2 times 2. What's 3 times 3? 4 times 4. 5 times 5, 6 times 6, 7 times 7. You get the pattern, right? 8 times 8, 9 times 9, 10 times 10. We could even keep going with 11 times 11 and 12 times 12 and 13 times 13. Yikes, I kept going, didn't I? 14, 15 is 225, 16 is 256, and 289 is 17. And of course it keeps on going. But the main ones you need to know are really just the perfect squares from 1 to 100. So now we're going to factor the perfect square trinomials. So we're going to break them back down. So x squared plus 4x plus 4, what times what gives you x squared is 4 and 4, x and x. What times what gives you 4? When it's a perfect square trinomial, it's always going to be the same, 2 and 2. And you can leave your answer like that, or you could say x plus 2 quantity squared. Either is completely correct, and we just want you to know that those are the same thing. X squared minus 6x plus 9, x and x. What multiplies to 9 but adds to negative 6? Right, negative 3, or x minus 3 squared. 9x squared. What multiplies to 9x squared? Right, when it's a perfect square trinomial, it's always going to be the square root. What multiplies to 1? But notice that the inner term there is negative. So, right, it has to be -1, -1, or 3x minus 1 squared. 4x squared, what multiplies to 4x squared is 2x and 2x, and what multiplies to 49, and it's all positive there, of course, is 7 and 7, or 2x plus 7 quantity squared. So it's the same process of factoring, but maybe just made a little easier because it's perfect square trinomial. The next factor pattern is difference of squares. A squared minus b squared is equal to a minus b times a plus b. You've seen this before. What multiplies to x squared is x and x, but what multiplies to -4 is positive 2 and negative 2. And this works because the outer term and the inner term basically do what? You're right, they drop right out. So it's x plus 2, x minus 2. It doesn't matter the order that you have the plus and the minus. X and x, what multiplies to -100? Right, you could say -10, positive 10, or you could say positive 10, negative 10. As long as it's a plain a squared or x squared or whatever. Oh, there's that 289. Do you remember what multiplies to 289? Right, 17. So it's plus 17 minus 17. Can get a little tricky, like here I see it kind of backwards from what we usually expect. And so our answer is a little bit backwards too. It's 5 and 5 minus 7x plus 7x. It would be incorrect to say 7x minus 5, 7x plus 5. 9y squared is 3y and 3y. And what multiplies to 144? Right, 12 and 12. Last one, what multiplies to 4x squared is 2x and 2x. And what multiplies to 25y squared? Minus 5y plus 5y. Difference of squares. So we've got the difference of squares factor pattern and the perfect square trinomial factor pattern.